All right, good morning. So questions. Questions about homework 6 in particular, but anything in general. Good morning. All right, well, let's go ahead and jump into some stuff then. So let me set this up. All right, let's talk about Git. So one of the things that's nice about using Git and GitLab or GitHub or a cloud-based repository is that it lets us share our work among multiple machines. And this can be really useful. It can also be kind of tricky. You can get into situations where Git sort of refuses to play with you. So let's take a look at how we can use GitLab to in this case, do some work on this, which is my own machine, right, my laptop, and keep it in sync with a repository on the Linux server, right? And let's see, so we have a question in chat. How do you recommend we study for the midterm? Make sure you know how to do all of the ODPs, make sure you know how to do the programming assignments, and that you're clear on all the concepts in there, right? I'm not going to ask you to reproduce that code, but how do you process command line arguments in Bash or in C? How do you parse input using fgets and scanf? How do you pick up extra stuff after an integer? Looping, conditional statements in Bash and in C, all of those constructs, right? Make sure you're good on those. And basic Linux commands like we talked about yesterday. That's pretty much the midterm. So 4 programming questions and some short answers. And just, refresh yourself on some of the code that you've been writing for the course, and that should be fine. All right, so let's make just a work repository. So again, I'm sitting on my home machine here, right? So this is just my laptop. And let's just make a work area. And I'm going to do my one-time git init, and I'm going to make a readme file. So there's a readme, and I'll make a main.c. Alright, so I got a couple of files in here. So I want to put them under git control. I'm just going to do git add, and those are the only things in my directory. So I can do star git commit, and there's my first check-in from the laptop. And then I want to push this over to GitLab. So remember, there's this one-time operation you do when you first begin a project. Before you've ever pushed it to GitLab, you have to do this git remote add origin git at gitlab.com : your GitLab username / and then what you want to call the repository. So I'll just call this git demo for lack of imagination. Git demo.git, and I'm going to say git push origin master. And if that all works correctly, that should push this over to GitLab and create this repository named git demo that'll have, in this case, 2 files. And so while it's working on that, let me go ahead and pull a file over. And so here's my GitLab setup. Yeah, Git's been really weird on me today and yesterday. I tried cloning something and it was taking forever too. I don't know what the deal is, except maybe that I'm streaming through Zoom and uploading some stuff at the same time. All right, so we'll suppose that that's going to work, and let me switch to analog mode here. So what I'm going to do is I'm going to log on to the Linux server. And I'm going to go to a directory below which I want to make a copy of my repository. So if I want my repository directly under my home directory, I'll just sit in my home directory. But if I have, a 224 area or something like that, I'll go into the parent of where I want this repository to be. So CD somewhere. And then I'm going to say git clone git at gitlab.com, my username, and then the repo name.git. And that will create a subdirectory under my current directory with this repository name, and that'll be a copy of my Git repository. Okay, let's see how that's doing. That is not doing. Let's try it again. Well, that could be a problem. Interesting. Well, I have internet access. And I can get to GitLab, but I can't ping it from here. All right. So I'm going to do this. It's going to make a copy of my repository on the Linux server, for example. And then once I'm in there, I can go ahead and I can edit my files. I can make changes to them. I can say git add. I can say git commit. And when I'm done making changes, I can do another git push and push it back up to GitLab. So here's going to be the setup. I'm going to have my laptop. I'm going to have my school server. And I'm going to have GitLab. And there's a repository here, and there's a repository here. So I'm going to make some changes to some files. I'm going to push it up to here. When I log onto the Linux server, I'm going to pull this down. The first time I do that with this git clone, and I get a copy of these files, I can make changes to them. I can check them into my local repository by doing git add and git commit. And then when I do a git push, it'll go back into GitLab. And if I make more changes, I can make those and then say git push and so on. And then at some point, if I come back to my laptop, the first thing I'm going to do is a git pull, which will pull down the current version of the repository and update my local repository to match that. And then I'm going to go ahead and make some changes, and when I'm done, as usual, I'll say git push. And I can do that as many times as I want. But then when I switch back to my Linux machine, first thing I'm going to do is a git pull. And if I had a third machine that I was working on, when I wanted to work on that, the first time I would do a git clone, and then again I would git pull, git push, git pull, and so on. And so you can have multiple repositories, right? And this happens in particular if you have multiple people working on a project. So 3 different developers on 3 different systems, and they're all working on a common set of code, right? The main set is kept on some sort of Git server, GitLab in this case. And when you want to work on a module, you go ahead and you pull it down to make sure you've got the latest version. You make your changes, you push it back up. And then later, if somebody else wants to work on that, they'll do a git pull. They'll have the version that you pushed up. All right. Hey, we got Git to work. All right. So let me switch to just my projects. All right. So here's my Git repo. So there's Git demo. Right. And I can go in here and I can see there's a README and there's a main.c, and all right. So this stuff is on my repository. So now let's hop onto the Linux server. It's weird, I still can't ping. Alright, so I'm sitting on my Linux server now and I want to start working on my project. So I'll go into my 224 directory and I'll say git clone git at gitlab.com, username gitdemo.git. Alright, and it creates a new directory, git demo, and if I go into that directory, there's all my files. And if I say git log, I can see my history of this, this was checked in from my laptop at 10:05. Alright, so I can make changes. Alright, so there's my new README. I can add that to the repository, git commit. And then git push origin master. And that pushes it over to GitLab. Okay, I come back in here, and on my laptop, right, my README is still my old README, of course, because pushing something to GitLab is not going to reach out and change what's on my laptop. But if I want to bring this up to date, I can say git pull origin master. Don't get laggy. It's going to get laggy. Alright, well that will finish, and then if I look at the README, it'll be the updated README. And then I can make changes here and push them over and so on and so forth. This is really weird. I've never had Git do this before, but like I say, I'm uploading a video and I'm also streaming Zoom, and I don't normally do those two things. All my upload's done. So maybe this is just a streaming thing, and I still can't ping GitLab. All right, so that's how it works, and if you do things like that, everything is fantastic. Where you can get into trouble is the following. I make some change over here, and I push it up to GitLab. So GitLab has this changed version A. All right, and then I come over here on the server and I pull down version A, and I make some changes to version B, and I push that up to GitLab. And then I go home and I sit on my laptop and I modify version A to version C. And now I try to push that up. Well, there's a good chance Git's going to complain, because I'm trying to push a version which is not an immediate variation on the latest version of this file that GitLab knows about. I'm trying to go directly from version A to version C, but GitLab is sitting there at version B. And it's basically going to say, I'm not sure how I should reconcile this. And the problem here is that, there were some changes made over here to version A, but I didn't start with those changes when I went to C. I went directly from an old version of this file to version C without first going through this set of changes. And that's a potential problem, right? So think about a collaborative environment. You're both working on a file. You're both at version A. Now this developer comes up with some amazing modification to the file called version B and pushes that in. Well, I come over here and I start with this old clunky version A and I make a new version C. I don't have the fantastic work that this developer did in version B. And if I push this up to the repo and it overwrites the current version with C, this developer's changes are lost. Right? So the system is trying to detect when this might happen, and it will generally refuse to let you push this. And it'll say that, there's newer changes here, than what you have in here. Okay, so things are out of sync at that point. And that's kind of a whole separate story of how we deal with that and how we get things back. Now for you, you're probably the only person developing this. And so if this happens, right, you have access to this modified version and you know what changes you made over here, and it's probably something cosmetic, right? Like not a significant change. So you can reconcile these and come up with a new version. Now, you can go back to older versions, right? I could go back to version A, and then I could pull down version B, and then I could make my changes for version C, and so on. And you can also have Git do some of this for you, and it will try to do a job of reconciling these things that are out of sync. But if you're doing this yourself, right, the absolute easiest way to deal with this is figure out what your correct version of the code should be, and then just force that in, right? Make a new repository, push that up there, and then add me as a reporter if this is going to be your homework 6. But you know, the best way to avoid that is just always keep things in sync. Okay, if you're starting on a new system, pull down your current version before you start making changes. Let's see how Git's doing. Alright, so it is pushing my code over. Alright, so I did my pull, and if I look at my README, it's got my new README in there. That was like the world's longest, most drawn out demo. Alright, so I can make more changes. Alright, so there's my README. I can add that. Let's push that over. And we'll go back to the long wait. So yeah, if you're the only one working on that, then yes, you can go back to an older version. So you can check out an older version. I'm not going to, probably, at least for now, I'm not going to talk about branching and those kinds of things, but that's kind of what this conversation leads into. This idea that you can start having multiple versions of your universe called branches, and you can do a bunch of development on one branch and then switch to another branch and so on. And if you're using branching correctly, then it's very easy to go back to a prior state, because it basically, you know, Dark City like just changes your entire universe to here's what things look like on this branch, and you've got new copies of all of your files as they looked when you were working on this other branch. And so if you start trying to add some new feature, you make a new feature branch, you've got copies of your code, you go ahead and you make your changes there. If at some point you want to go back to where you were before, you just check out a different branch, and it looks like the way things were before. And if you're doing that, that makes it a little easier to manage these kinds of things. Yeah, so that does mean that you can't have a team of top-notch developers working on your homework with you. That's a good conclusion. All right, let's see. That's going to take forever to push. All right, so the other thing that you can get into trouble with Git that you've probably discovered is if you, for example, delete a file by saying rm, and you're putting things under Git, sometimes it will get upset at you, right? So if you remove a file, you want to make sure you do it through Git, like git rm. And if you rename a file, do it through Git with git mv. And then that not only removes or renames the file, but it also tells Git that this is what happened, so that when it notices the file is missing, it doesn't kind of freak out and say, wait a minute, things aren't in sync anymore. So yeah, Git is working pretty hard to try to keep you from getting into trouble. But that can mean sometimes, you know, you have to sort of take care of Git. Alright, so here's my old README. If I want to start working on my Linux account now, just git pull origin master, right? It's the opposite of git push. And that should bring down the repo, and there's lots of information here that we don't really need to worry about. But basically, README got updated, and so there's the current version of the README. And you keep going from there. All right, so that's a little bit about using Git to work on multiple machines. There's a whole lot more to it, but if you just want to sort of keep things in sync between your home system and the Linux server, that gets you most of the way there. The other option, of course, is to not use Git to do that. You just use something like tar files and push things back and forth. So let's talk a little bit about tar, because this is something that's come up a few times. So think zip files, right? A zip file is a way to take a number of files and put them into a single file, something .zip, and also do some compression. And now if you want to copy a bunch of files from one machine to another, well, you zip them up and you just move that one zip file. Okay? A tar file is exactly the same thing. Let's see, question, why don't you need to specify what you want to pull from Git? Because I already did that Git origin setup business, right? This repository here is linked to gitlab.com, Nick Macias, gitdemo.git. And you do that either by doing that one-time git remote add origin, or by doing the git clone that I used to create this originally. All right, so a tar file is the same idea. Tar is a way to take a collection of files and bundle them together into a single file. Okay, and files in Unix can have any extension you want, but usually we call these things .tar. And tar has a whole bunch of capabilities. So, big man page with lots of features and stuff like that. I'm only going to show you 3 tar commands. And honestly, these are the only 3 tar commands I've ever used since I stopped working with actual magnetic tape. And tar is a version of R. R is the archive routine. Right, so create, modify, and extract from archives. Tar is the tape archive version, so it was a version of R made for working originally with magnetic tapes. We don't use magnetic tapes much anymore, so but we still use tar. So here's 3 tar commands. And tar is unusual. It's one of the few Unix commands that does not use a dash in front of the arguments. Okay, and this is important. So here's the 3 tar commands. Tar cvf archive name file 1, file 2, file 3, and so on. Okay, tar cvf archive name, and then a list of files. And this creates an archive. All right, so C is saying create, V is saying be verbose, and F says instead of going to the tape drive, use a file. And that's got to be followed immediately by the name of the file that you want to create, the archive file. And then a list of files. All right, so can I go somewhere more interesting? All right, that's fine. So I'm sitting in a directory here, okay? This is my Canvas directory for 224 this fall. And I want to bundle all of this stuff up into a single file. So I'm going to say tar cvf and I'm going to put this in my home directory, so 224.tar. That's the name of the file that I want to create. And then I'm going to list all the files I want to put in there, where I'm just going to say star. I want everything to go in here, and this will automatically go down into subdirectories. So tar cvf, name of the output file, and then I'm just saying star for everything. And it shows me all the stuff that's being added to this archive. So there's a documents directory, there's some files inside documents, there's an images directory, and there's some files inside images. Alright, now if I go into my home directory and I look, there's my file 224.tar. Okay, second tar command, tar tvf archive name. So cvf, this is create. tvf is look at. T is for table of contents. So I want to look at the table of contents with verbose information on this archive whose file name is archive name. Alright, so I'm going to say tar tvf 224.tar. And it shows me something that looks like an ls-l. Right? There's a directory named documents. I can see it's a directory over there. Here's some files in documents. Here's the images directory. There's some files in images. I should have tagged this earlier. Alright, so, and this is recording all of the information about my, my file system. So I've got, you know, the file size, the date and time of creation, the owner, the group, and all of the protection bits. And all that information is preserved in your tar file. Okay, if you're running on a system that uses you know, a file system that doesn't understand permission bits, for example, in the same way that the Linux file system does, or uses different timestamps or things like that, right? Just moving these files around, you can lose information. A tar file is going to save all that information for you. Okay. And then I have one file, and for example, you know, I could push this file over to my Linux machine. So I could put 224.tar. And then over here on my Linux machine, there's my 224.tar. So I can make a directory called copy. And now I'm going to do my third and final Linux command, which is tar xvf archive name. And this says extract. So the X means extract. So this untars basically. Alright, so I'm going to sit here in my copy directory and I'm going to say tar extract verify file /224.tar, and it will pull those files out of my archive. And now I've got two directories, documents and images, and it's got, you know, all of my files in there with my permission bits and timestamps and so on. So so three tar commands: create an archive, look at an archive, extract from an archive. Okay, extracting from an archive does not change the archive. So the 224.tar file is still intact. I can extract from it again, and this is also a nice way to do backups locally sometimes. Take all your work, tar it into something, and just keep that around, and anytime that I want to go back to a file, I can untar this, and you can untar exclusively, and so on and so forth. Alright, so that's another way to move files from machine to machine. And tars are nice. You can also zip them. Tar does not compress. So if you have a lot of text files, tarring them up will leave you with a really large tar file that might zip down very nicely. And typically when you use gzip on a tar file, you would get, you know, something.tar.gzip. And those usually are renamed .tgz. So that's a tar file that's been gzipped. That's also called a tarball. And this was one way that you used to find a lot of packages distributed online, was just as tarballs. You'd download them and you'd unzip them and untar them. Tar will unzip automatically. And yeah, I do mean CVF without a dash. You can put a dash in that case, but some of these you don't want a dash. So I just never put a dash on any of my tar switches if I'm only using these three: CVF, TVF, XVF. Alright, let me show you how you get in trouble with tar. Okay, don't do this. This is another case where if you're going to use tar, don't make your first experiment with it on your final project an hour before it's due. Okay, go into a totally safe area with junk files and experiment with this. Figure out how to make it work. Figure out how to get in trouble with it. Right, because if you don't do that, then you don't know how to avoid it. So let me show you how you get in trouble with this. So let's clear all this stuff out. Alright, so I'm writing some really incredible code here. Alright, so I've got 3 files in my directory, and I want to put them into a tar file. Okay, so don't do this. Alright, tar CVF star. Alright, and then, you know, I look around, where's my tar file? Oh, I forgot to name the tar file. Okay, tar CVF, you know, save.tar star. Alright, and then I turn in save.tar to my teacher, and I go away and I'm done, right? Alright, something really bad has just happened. So, so let's take a look at save.tar. So do a TVF, yeah, it's got main.c, main.h, and zebra.c. That looks great. I'm convinced now, my project's done. I'm gonna go off to the beach for the weekend, right? Okay, let's actually extract the stuff from this archive. Tar xvf, save.tar. Alright, so now I'm getting ready to look at your code, and I say gcc-c main.c, and I get all kinds of weird stuff in here, right? And what the heck's going on? So I take a look at main.c, and this is what it looks like. So now I send you an email and I say, hey, your main.c doesn't look right. Please double check what you sent me. Alright, so you're back in your directory here. Here's your original code, and you say, huh, what's wrong with my main.c? Oh no, right? Your C program doesn't exist anymore. It's been corrupted. Alright, so what happened? What happened was way back here when you made your tar command, you said tar cvf star, you didn't list the name of the archive to create. Okay, well what happens when you type star in bash? It gets replaced with all the files that match that wildcard, which in this case is main.c, main.h, and zebra.c. So effectively, the command that you typed was the following. You basically said tar cvf main.c main.h zebra.c. Well, what does that command ask Linux to do? It asks it to create an archive named main.c containing these files. And when you executed that command, you can see it added exactly 2 files, main.h and zebra.c, and it put them into a file called main.c. Now main.c already existed. That was your C program. It got overwritten, right? And it's not going to warn you, you know, main.c already exists, would you like to overwrite it? Because that's a pain, right? When you're writing an archive file, you're probably going to write it multiple times. You don't necessarily want to have to answer a question every time that you want to make a new version of this archive. So by default, it's not going to ask you, are you sure you want to overwrite this, right? That would have saved us in this case, but tar acts silently unless something goes wrong. So this command right here basically destroyed my original main.c. And it's still there when I do ls, but it's an archive. And then when I did my tar command correctly to create save.tar, it put my corrupted main.c into that tar file. And then that's what, you know, your teacher ended up looking at when they untarred your file. All right, so you got to be a little careful with tar. Again, if you're using Git, you're making backups, you're pushing things over to the repo, your project's all set to go, you've just pushed it over to GitLab, you make a tar file. If this goes on, if this gets corrupted, just pull down the version from Git, right, and get your file back. All right, so make sure you got good backup habits. All right, so that's a little bit about Git, that's a little bit about tar. Let's see. So yeah, exactly. When using the tar command, it's like putting a group of files into one archive, which in some sense is, you know, kind of like making a zip file or something. But the advantage is, you know, then you have a single file that you can copy to a flash drive or push over to another machine, or you know, write on a clay pot or whatever your preferred backup method is. And it preserves all of the directory structure and all the information about the files and so on. So yeah, the files that you push into the tar file do not get changed, right? And if I hadn't made this mistake, if I had done this correctly originally, and you know, named an archive, then all three of my files would have remained unchanged. So it reads them, but it doesn't change them at all. Now, if you extract, right, that will overwrite files that are already in your directory, and that can change them. So you can't directly compile a tar file, but you could extract from the tar file and then compile those C files and link them into an executable. The tar file is a partially binary format. I think I got rid of my tar file. Nope, it's still there. Right, so it's semi-human readable. You know, it's got some information like directory names and some file names and some permission bits that we can read and so on, but it's a lot of binary information. And I'm pretty sure tar will overwrite without commenting, but let's see. So there's my save.tar. So let's make a new version of Zebra. So let's extract that. And yeah, it just goes back to the old version. So tar will overwrite existing files. And there's switches, I'm pretty sure, that you can put on that to you know, have it ask, or maybe have it not overwrite by default. But just straight tar is just going to replace anything that's in the way. So you can get in trouble with it, but mostly it's a really useful utility. All right, good. Other questions? And then if you want, you know, you can say gzip the tar file, and that'll give me a save.tar.gz. That's the zipped version. And where is the save? Well, so right now it's 277 bytes. Whereas unzipped, it's 20,000. It's 20,000 bytes. So, you know, 10x reduction in size. Yeah, tar is like a bulldozer. That should be a song lyric, man. Tar is like a bulldozer. Okay, maybe not. All right, any other questions on that? All right, so let's start talking more about string processing in C. Um, and this is stuff that will relate to homework 6. Okay, your stick program for processing user input when you're supposed to say high, low, or correct. But it's general stuff that will be useful for working in C. And I'm thinking homework 5 or programming assignment 5 is going to be about a lot of string processing. So let's just look at a few things we do in C. So let's have a character array. So there's my favorite character array, buffer, 120 characters. And let's say f gets name of the array, size of the array, where we want to read from. And so if the person says, you know, hello, and types enter, buffer ends up looking like this. And fgets keeps the new line on the end, and then it puts a null terminator, and then all of these other locations are unchanged. So they have whatever might have been in there before we called fgets, which is effectively, you know, random. All right, so once I've done this, if I make a query, what's the string length of buffer? It's going to say 1, 2, 3, 4, 5, 6 things before the null terminator. String length is 6. And you can think of it as kind of literally counting 1, 2, 3, 4, 5, 6. If you think of that enter as a new line, then this string is 6 characters long. 5 letters and then a new line character. And sometimes that's convenient to have a new line at the end, like if you wanted to print out buffer, you wouldn't have to say, you know, %s\n. But a lot of times, we don't really want that new line sitting there at the end. We really just want a string that's equal to, you know, the actual keys that the person typed, HELLO. And we would like to get rid of this new line. All right, so in this very particular case where this is exactly what my buffer looks like, what one assignment statement could I make that would change my string to actually just be 5 letters, HELLO? And you can pop something in chat if you have an idea. So one assignment statement. Crickets. There we go. So someone said buffer bracket 5 equals quote \0. Awesome. So if I were to make this one assignment statement, what's going to happen? Well, this character of the array, right? Remember, this is just an array. This whole thing is going to change to \0. Well, as soon as that happens, anytime that anything looks at this string, string length, string compare, printf with a %s, what's the string going to look like? HELLO, and that's the end of the string. So by overriding that new line with a null terminator, we basically truncate the string to end right before that new line. All right. Now, if our string was high, followed by a new line, the string length would be equal to 3, 1, 2, 3. This would be character 0. This would be character 1. This would be character 2. There's a null terminator sitting at position 3. If I want to truncate this string to remove the new line, where do I put that null terminator? I put it in position 2. All right. So humans are really good at finding patterns, right? This is one of our things. If the string length was 6, my trick was to set element 5 to a null terminator. If my string length is 3, my trick is to set element 2 to a null terminator. So let's generalize. And say, what if I do that? So if I do buffer bracket string length buffer -1 and set that to a null terminator, that should remove whatever the last character of the buffer is. And if I know that the last character is a new line, this will basically get rid of that new line. Yeah, awesome. All right. So if the last character was not a new line, if it was, the letter D, then that D would get replaced by a null terminator. But usually when we do fgets, as long as our input is smaller than 119 characters, the last character will be a new line, and this will get rid of that. So that's something you'll see a lot of kicking around in code, and it's just a little thing to chop off that new line if you want your input to be actually the characters that were typed in without that extra \n at the end. But it's an example of a more general concept, which is being able to manipulate these strings as collections of characters, right? So chopping off the last character, pretty straightforward. And if you wanted to chop off the first character, that's a lot harder. Because if I wanted to get rid of this H, what would I need to do? I'd need to actually move my E up here, and my L, and my L, and my O, and my null terminator. That's something that might need a loop. But to get rid of the last one, right, we don't need to actually move anything around. We just need to say, hey, the string ends here instead of there. And so that's a really easy thing to execute. All right, so I want to look at strings more generally next week, and look at comparing strings and how string length works and things like that, before going back and jumping into some more Unix stuff. But we'll do a little more string processing Monday. All right, so midterm tomorrow. Please show up on time. 55 minutes for the exam. I will see you then. All right, bye.